welcome to this explainer. Today, we're unpacking a massive shift in AI, using Dr. S. Mahesh Anand's definitive guide, Ultimate Multimodal Transformer Models. We're going to look at exactly how AI evolved from literally struggling with basic sentences to completely mastering vision and language. Okay, let's dive into this. For years, classical AI was the absolute gold standard, right? But then, it just hit a brick wall. You might be wondering, why did it suddenly stop scaling? Well, those early machine learning models essentially failed at processing long sequences of data, like text, which created this totally insurmountable AI scaling wall.
The root of the problem was the sequential bottleneck. Basically, classical recurrent neural networks, or RNNs, had to read text sequentially, just one word at a time. It's kind of like trying to read a whole book through a tiny keyhole. This created a massive bottleneck that totally blocked parallel training on modern hardware. Plus, it caused these networks to suffer from vanishing and exploding gradients, meaning they literally just forget the beginning of long texts by the time they reach the end.
So, classical AI was pretty severely limited by those bottlenecks. But then, the 2017 Google Brain breakthrough paper, Attention is All You Need, absolutely changed the game. It introduced the transformer architecture. And the huge shift here? Instead of reading word by word, transformers can process entire sequences simultaneously. And this brilliantly illustrates the difference. Imagine walking into a room and seeing everyone at the exact same time, rather than meeting them one by one. That's what the transformer does. It reads the whole room at once. This parallel architecture perfectly leverages modern GPUs, completely obliterating that scaling problem that held back classical AI. Now, you might be asking, how does it actually understand a whole sequence all at once without a fixed reading order? It's all thanks to the magic behind the architecture, a mechanism called self-attention. It dynamically evaluates and assigns significance to how each word relates to literally every other word. So it immediately connects a word like cat to cute, regardless of where they actually sit in the text. This shift also completely changed how AI mathematically represents language. Classical models use these rigid, static embeddings, like a fixed dictionary, but transformers, they use fluid, contextual embeddings. Think about the word model. With contextual embeddings, its mathematical meaning instantly adapts based on whether the surrounding sentence is talking about a machine learning algorithm or a fashion runway. Let's move on and see how this builds, because this parallel architecture definitely didn't stop at just text. It sparked a full-blown multimodal revolution. Today, we have vision transformers analyzing pixels, vision language models like Clip and Flamingo bridging images and words, and agentic workflows actually taking action. AI isn't just reading anymore. It is seamlessly seeing, reasoning, and acting across audio, text, and images. To truly master these groundbreaking systems, Dr. Anand's book is basically your vital survival guide for this new era. Mastering these advanced models, especially using industry-standard tools like PyTorch and Hugging Face, is absolutely essential if you want to stay at the cutting edge as a tech professional today. The future of AI is undeniably multimodal, and this shift from sequential models to parallel transformers is moving incredibly fast. So the real question is, are your skills ready for the transition? It is time to dive into the source material, urgently upskill for this new frontier, and get building. Thanks for hanging out with me for this explainer.